Mattias é um desenvolvedor JavaScript que soluciona um cubo mágico em menos de 2 minutos, mas nunca conseguiu fazer uma estimativa de tempo correta na sua vida. O que não é problema, já que ele sabe muito bem otimizar suas atividades. Responsável pelo Function, um canal sobre programação no YouTube, o sueco trabalha em uma das mais complicadas aplicações HTML do mundo, o cliente desktop do Spotify.
Good Friday evening, BrazilJS. Have you had a good first day? That's kind of like a Swedish response to that. I wanted like a more Brazilian one. Have you had a good first day? Thank you. Are you tired? Are you tired? Mentiroso. Good. All right. So, I am going to show you 2 sentences that you will not understand. And also because it's not on the screen. I think I need to get out of this somehow. Exit full screen. And drag it to, oh, there it is, there it is, there it is. Fantastic. So if you understand these 2 sentences right now, you can like go away, have a cup of coffee, because you already understand everything that I'm going to tell you in this talk. The 2 sentences are, a functor is something that you can map, and a monad is a functor that you can flatMap. So tonight we're going to try to chip away at these 2 sentences and hopefully understand them at the end. So let me give you an overview of how we're going to get there. We're going to look at 4 different functors: array, tree, stream, and promise. All of these belong to the family called functor, because we can map them. Stream and promise, however, belong to the monad family, because we can flatMap them in addition to mapping them. So we're going to look at how map works on all of these, all of the functors, and we're going to look at how map works when it comes to stream and promises, the monads. So, first of all, we're going to remind ourselves what map really does. So many of you are familiar with what map does, but we're going to talk about that a bit more. So functor is a fancy pants word for something that we can map. For example, arrays in JavaScript. Arrays have a method called map. Arrays can be mapped, and arrays are therefore functors. So let's talk a bit about array map. Many of you know how it works, but let's really think about it for a bit. Let's say that we have an array, giving the audience what they want. An array of Portuguese words: galinha, vaca, and milho. Let's say that we want to make a new array of these words, and we want them to be capitalized. And thankfully, there is a function in the Lodash library that does this for us. It's called capitalize, and you pass in a string, and you get the same string out, but capitalized. So we're halfway there. Nice. Now, in order to capitalize the entire array, we pass the capitalize function into the map method of the array with Portuguese words, and we get out an array of capitalized Portuguese words. This system is flawed. So let's look at how this works. So map is a method on array that takes a function. In this case, it takes capitalize, and I'm going to refer to this function as the mapper. Map will go through all the elements in the array one by one, and it's going to pass each element into the mapper, capitalize. And map expects the mapper to take this value and return a new value. And this is what capitalize does. It takes a string and it returns the same string, but capitalized. And map is going to do this for every item in the array, and it's going to finally return a new array with all of the words that are generated by capitalize. So let's think about this in an even more abstract way. You can think about an array as a set of, like a line of boxes that is glued together. And the boxes, we can put things in those boxes. And I know that's not a chicken, but they were out of chicken. Give me a break. And we can put things in those boxes. And over here, we have a cooking function. And this cooking function, he knows how to cook chicken, cow, and corn. But he's a very focused and good cooking function, but he's so focused on cooking that he does not know how to cook arrays of food. He's very focused on that, so he can only cook singular items of food. So in order to solve this dilemma, we put a function in between cook and the array called map. Now, map doesn't know anything about chicken, cow, and corn, and it doesn't know anything about cooking. But map knows one thing. Map knows how to take things out of arrays, shove them into mapper functions, and take whatever comes out of the mapping function and shove those items into a new array. And this is, on a conceptual level, what map does. So we're trying to get our brains around this function, get used to this. A functor is something that you can map. And we looked at the functor that we all know and love, array. But what about thinking more broadly? What about thinking about other functors? Can we map something else? Let's invent a tree functor. A tree that we can map. So let's have a look at my family tree here. I am at the top, here, and below me are my parents, Eva and Mats. And below them are my grandparents, Ove and Sonja and Anna and Gustav. I have not included my great-grandparents because I am a historyless millennial and I don't even know their names. But I do know that my grandmother Sonja was a pharmacist, and my grandfather Ove was a postman who later in life got a very successful career as a painter. Either way, we want to do the same thing to my family tree that we did with our array of Portuguese words. And by that, I mean that I want to capitalize them, not that I want to cook them. So our goal is the same tree, but capitalized, like this. And like a good TV chef, I have prepared a function, map tree. So this is the entire source code of MapTree. It's not super important what this does. I'm not even going to go through it. I'm only showing it to you to show that there's no weird stuff going on. It's just some JavaScript. It is recursive, because I have the emotional need to impress you people, but it's still just some JavaScript. There's no libraries or special native functions or anything. So the important thing is not how it's implemented, it's how we use it. And we use it like this. And this is going to give us what we wanted. My family tree, but capitalized. And when we're looking at this tree example, I want you to start seeing map as a concept. So map is not just a method on the array object, and it's not even a function like map tree. It is a concept. It might be implemented as an array on an object like array is, but it might also be implemented like this. A simple function that takes a tree and a mapper as its arguments. It's still a functor. And most functional libraries actually re-implement array.map as a simple function, so that you just can call it like that. So this is low-map function. So these two here, they do exactly the same thing, and it's all valid. It's all functors. The style of how we implement map doesn't matter. It's that we get the concept right. So let's think about how map relates between tree and array. So we have this string of Portuguese food, or this array with strings of Portuguese food, and we have this little function called capitalize that knows how to capitalize individual strings, but it doesn't know anything about arrays. So, however, our friend Map here knows about arrays, but that's the only thing she knows about. She doesn't know how to deal with strings, and certainly not how to capitalize them. But that's cool, because we can give her capitalize as her mapper, and with that, they can work together and give us a capitalized array. And in the same way, we have here, over here, my family tree, and it's lowercase. It needs the help of capitalize, but capitalize doesn't know anything about trees. But luckily, we've written a sister function to array.map, map tree, which is here, and we can give capitalize the same function that we can reuse here, and they can work together to give us our family tree capitalized. And what you're looking at here is the entire point of functors. It allows functions to operate on a data structure, or rather the element inside the data structure, even though they were not specifically built for that. So again, we have an array that we want to capitalize, and we have a function that can do that for us, for the individual items. And if we didn't have functors, we would have to create some kind of loop, perhaps, to do this for us, to glue these together. But if something is a functor, we don't have to do this work at all, because this work has been done for us, like this. And functors is a big part of why code that is written in a functional style tends to be a lot less code, like surprisingly little code for what it does. And I really want to stress here that this is not because the syntax is shorter. It is because we are genuinely writing less logic. We are doing less work. And the reason that we're doing less work is because everything is contained in these small, simple functions that just work well together. They just click. So far in this talk, we've learned that arrays in JavaScript are part of the functor family because they can be mapped. And we then made a tree mappable to demonstrate another example of a functor. Let's look at a third functor, stream. You might be familiar with streams from this morning's talk by our own British Ned Stark. Or you might have heard them being used in hipster libraries like RX or Bacon or Highland, or perhaps you've seen them in Node.js. But just in case, I'm going to give you a crash course on what streams are. And I personally think of streams like arrays, but that they are asynchronous. And that's a very abstract thing to say, so I'm gonna show you some code. So this is a pretty dumb example that I made to show you the idea behind a stream. Let's walk through it from the bottom. So what this code will do is it's going to print Galinia after 1 second, Vaca after 2 seconds, and Milieu after 3 seconds. And it does this because we have passed this callback to the onValue method of the stream. And food stream is created here by calling create stream of food, which is declared up here. And if we look inside that, we just see that it's just faking some values by sending them to the callback and delaying that using setTimeout. So conceptually, food stream is a data structure that will give us our list of Portuguese words, but it's going to give them to us like later in the future as they come along. And to get the values, we need to listen to the stream by passing a callback function to its onValue method. And that callback will be called with the food items as they arrive in the future. And this is the essence of what a stream is. Stream libraries such as the one in Highland or Bacon.js or whatever really, they have a multitude of other functionality. They're not useless in any way, but in the end, the core concept of a stream is that it is a pattern to deal with a flow of values that are coming in whatever order and pace that they gosh darn it feel like. So this could be like data, like we saw in the example this morning, but it might also be chat messages, click events, logs, etc. And if you've seen Redux, it's the view state in that. It might be many things. But let me show you this same example, but implemented using Bacon.js. There are many types of streams in Bacon.js, but I like this one, bacon.bus. It has an onValue method that we can use. It's just like the one in our fake stream implementation. We pass a callback for it, and we can use it to get values out of the stream. And it also has a push method to push values into the stream. And I like Buzz because it feels very much like an asynchronous array. But remember that we're here today to think about what functors are. So remember that a functor is a word that we use to describe something that we can map. And pretty much all streaming libraries implement map on their stream implementation. And Bacon.js is no exception. So now we're going to do, again, the same thing that we did to our array and to our stream. We're going to capitalize these values. These two lines here, that's all there is to it. We require in Lodash, and then we then pass Lodash capitalize to our map function, or to a map method on the food stream. And map will then return a new stream, but where every value has been fed through capitalize. So notice here that this is the exact same principle as mapping trees and arrays. Mapping an array will return a new array. Mapping a tree will return a new tree, and mapping a stream will return a new stream. So the general concept, if we generalize it a bit more, is that map accepts a mapper function, creates a new functor of the same type, where every value has been transformed to a new value by the mapper function. And perhaps you're starting to see how this fits together. We have values that we want to transform, like our Portuguese words, and we have functions that can transform those values, but the values tend to be stuck in these data structures like trees, maps, and streams. And this is where functors come in. Because if we have functors, the problem has been solved for us. Because map will act as sort of an adapter between capitalize and our functors. Lodash doesn't know anything about bacon, and bacon doesn't know anything about Lodash, but because capitalize and other similar helper functions are implemented as simple pure transform functions, and our data structures are implemented as functors, they just click together. And this means that you don't have to write any glue logic to make them fit. And this is the power of functors. So, how far are we in this talk? Let's remind ourselves of the two sentences that we are trying to understand. A functor is something that you can map, and a monad is a functor that you can flatMap. Let's talk about flatMap. All right, so now here's going to come the hard part. I'm going to give you the description of what flatMap is, and it's a bit tricky, and it's late in the day, evening. So I want you to breathe and concentrate. FlatMap is just like map, except that FlatMap does not expect the mapper to return a value. Instead, FlatMap expects the mapper to return a functor containing the value. And flatMap will take that functor and flatten it into its actual value. That feeling of confusion is your friend. Means you're learning. You're doing good. Stay with me. Let's build an example. Let's say that we have an array of Portuguese food words and we want to translate them to English. And let's say that we have written a function that can do this using the Google Translate API, get in English. And the exact code here is not very important. It does a fetch call and it parses out the response and it gets the translated word. It's not so important. What I want to draw your attention to is that it takes one argument, the word, a string, and it will return a promise which will resolve into the translated word. With that in mind, now let's go back to the stream example where we were before. I'm now going to remove capitalize, and I'm going to replace it with a call to get in English. Notice that we're using map here, We're not using flatMap yet. So if I run this, it will print something like this. Not very useful. Map isn't very smart. It just takes whatever the mapper returns, which is a promise, and shoves it into the stream. And that's what it did here. But what if there was a version of map that could get sort of into the juice of these promises, get that out? What if there was a method that could flatten these promises into their actual values? flatMap. Now, this will not work yet. So remember that flatMap will expect, it wants its mapper to return a functor with the value in it. And Get in English does that. It does return a promise, which is a functor, but it's the wrong type of functor. It's a promise, but we're flat mapping a stream here. And streams and monads only knows how to flatten monads of the same type. So it expects a stream to be returned from the mapper. Luckily, there is a function in Bacon, a helper function, that can convert promises into a Bacon stream. Because essentially, a promise is just a stream, but it's a stream with one value. So that works like this. We pass the result from Get in English, the promise, into bacon.fromPromise, which will return a stream, which the mapper will return to flatMap, and flatMap will flatten it, and then return a new stream, which we call onValueOn, and print the value, and we get our array of our stream of translated words. So this is mission success. And just for kicks, we can mix in map and capitalize back in, which will give us the values translated and capitalized. So again here, flatMap is just like map, except that flatMap does not expect the mapper to return a value. Instead, it expects the mapper to return a functor containing the value, and flatMap will then take that value, functor, flatten it, and return a new stream with those results, flattening. So a monad is a functor that you can flatmap. So we talked about the stream monad, and I promised you at the beginning of this talk that we would talk about the promise monad. And promises are, as I said before, they're kind of like streams, but they only emit one value. And promises were popularized by jQuery back in the day, and they have been used by JavaScript developers for many years. And they've become part of the language in ES6. So promises are probably the monad that you're using the most, even though you might not be familiar with the fact that they are part of the monad family. And in fact, some of you might be thinking, if you're clever here, promises don't have a map method. Promises don't have a flat map method. How could they possibly be monads? And there is an annoying and important thing that I have up until now shielded you from in this talk, and that is the fact that flatMap might not have the name flatMap. Some languages call it chain. In Haskell, it's called bind, which would be an insane name to use in JavaScript because we already have bind, and that means something completely different. And that is why I've been trying in this talk to get you to think about map as a concept, because the names of these things will be changing around for you. So promises in JavaScript actually take even more freedom with this, and they take flatMap and map and bundle them together into a single function that is called then. And this is why there are many people saying that ES6 promises are not strictly monads. But I think that it's sort of like when some asshole says that bananas are not strictly a fruit. They are, botanically speaking, a vegetable. And it's in the fucking fruit section. Either way, let me show you the stream example again, but rewritten using a promise. Since it's a promise, it can only have one value, so I've left the best one, the cow. So we create a promise that resolves into vaca after 2 seconds. We then pass get in English to the then method. So notice here that previously this was flatMap in the previous example, but we're using then here. And then we'll have exactly the same effect as flatMap. Another interesting example here is that we are not, the conversion code that we had before, we don't have to do that here, because when food is a promise, and when a promise flatmaps, it can, like, get in English will return a promise, and when food is a promise, so the then of when food will know how to deal with that return value. So we don't have to do any conversion. Promise monads knows how to flatmap other promise monads, just like stream monads knows how to flatmap other stream monads. And we can chain our calls here as well. Just like array.map returns a transformed array, promise.then will return a new transformed promise, which we can call then on. And that will in turn return a new promise where every value, or the only value, has been fed through capitalize. And on that promise, we can again call then and log the return value out. So notice here that we pass capitalize to then, just like we passed it to map and on the stream. On this line here, this was map in the last example. And the reason that we can do that is because then behaves automatically like either map or flatMap, depending on the circumstances. So if the mapper returns a functor, a promise, then will behave like flatMap, and if it returns any other value, a non-functor, it will behave like map. So, again, promises are monads. It's just hard to see because promises bundle map and flatMap together into a single function that they call then. So we're back to where we started. A functor is something that you can map, and a monad is a functor that you can flatMap. When a data structure implements map or flatMap, it kind of exposes this slot in the data structure where we can stick a function and have that function operate on the individual elements in the data structure. And because of this saves us from writing a lot of glue code that we would otherwise have to write in order to operate on the items in the data structure. And I hope that this talk made you feel good in your brain. I work at Spotify, and you should come work there. If you didn't know it, the Spotify desktop client is written almost entirely in JavaScript, and it's one of the more complicated JavaScript applications in the world. We've been very happy with the Brazilian JavaScripters that we have, and we would like to hire some more. We're hiring in New York, San Francisco, and Stockholm at the moment, so apply. And finally, and most importantly, if you don't know it from before, I run a YouTube channel called Fun Function. It's a programming show with a lot of stuff like this, and I do new episodes every Monday morning. Please check it out. That is all. Obrigado!